What is a spherical mirror? Spherical mirrors are mirrors whose surfaces form a part of a hollow sphere. The spheres can be made of glass or any polished metal surfaces. Types of spherical mirrors. 1. Convex mirror. 2. Concave mirror. Convex mirror. If the mirror coating is in the inside of the spherical surface, then the mirror is called a convex mirror. Concave mirror. If the mirror coating is on the outside of the spherical surface, then the mirror is called a concave mirror. Some definitions of convex and concave mirrors. 1. Center of curvature. The center of curvature of the mirror is defined as the center of the hollow sphere from which the mirror has been cut. It is represented by the letter C. It can be observed that C of a convex mirror is behind the mirrored surface. On the other hand, C for a concave mirror is in front of the mirror. 2. Radius of curvature. Radius of curvature is the radius of the sphere from which the mirrors is made. It is represented by the letter R. 3. Pole of the mirror. The central point on the surface of the mirrors is called the pole of the mirror. It is represented by the letter P. 4. Principal axis of the mirror. A straight line that passes through the center of curvature C and the pole P of the mirror is called the principal axis of the mirror. 5. Aperture of the mirror. The portion of the hollow spherical surface from which the mirror reflections take place is called the aperture of the mirror. 6. Focal length of a mirror. When parallel rays of light coming from an infinite distance fall on either a concave or a convex mirror, they are reflected back to a point on the principal axis. Focal length of a concave mirror. In a concave mirror, the rays appear to converge at a point F. The distance PF is called the focal length and F is called the focal point. The focus is in front of the mirror. Focal length of a convex mirror. In case of convex mirrors, the parallel rays, on reflection, appear to diverge from a point F. This point again is called the focal point of the convex mirrors, and the distance PF is called the focal length. The focus, in this case, is behind the mirror. Rules of reflection for curved mirrors. 1. Any light ray traveling parallel to the principal axis is reflected by the curved mirror through the principal focus. It either actually passes, for a concave mirror, or appears to pass, for a convex mirror, through the principal focus. 2. Any light ray that passes, for a concave mirror, or appears to pass, for a convex mirror, through the principal focus is reflected by the curved mirror parallel to the principal axis. 3. Any light ray that passes, for a concave mirror, or appears to pass, for a convex mirror, through the center of curvature retraces its initial path after reflection by the curved mirror. Characteristics of the image formed by a concave mirror according to the position of the object. Characteristics of the image formed by a convex mirror according to the position of the object. Uses of concave mirror. Concave mirror is used as a reflector in headlights of vehicles. Dentists and ENT specialists use concave mirrors to see small inner parts of throat, nose, etc. It is used as shaving mirror. Concave mirrors are used in telescopes. Uses of convex mirrors. Because convex mirrors produces small, virtual, upright images, they are well suited for security mirrors, rear view mirrors. Thanks for joining today's journey. If you enjoyed, hit like, subscribe, and turn on notifications. Your support is invaluable. Share the video with friends to spread the knowledge. Grateful for your time. Stay positive, stay curious. Until next time. Subscribe now, share the love.